the legendary X-15. Ladies and gentlemen, distinguished guests, and fellow seekers of knowledge, today we journey back to a remarkable era in aerospace history, a time defined by bold ambition, fearless experimentation, and a relentless pursuit of the unknown. At the heart of this chapter stands a machine whose name has become synonymous with innovation and courage. A machine that did not simply fly. It redefined what flight could be. This is the story of the legendary X-15, a vision beyond limits. In the late 1950s, the world was changing rapidly. Jet engines had only recently taken humanity beyond the speed of sound. Satellites were beginning to orbit Earth, and the dream of spaceflight was slowly shifting from imagination to reality. Yet there was an enormous gap between airplanes and spacecraft, a mysterious region where the atmosphere grows thin, the air grows hot, and the rules of normal aerodynamics no longer apply. Engineers asked a question that would change history. What happens if we go faster than anyone has ever gone, and higher than any aircraft has ever reached? To answer this, the X-15 was born, not as a weapon, not as a commercial project, but as a scientific instrument, a laboratory with wings, a vessel designed to confront physics at its most extreme, a machine forged for the impossible. The X-15's very form reflected the ambition behind it. Its sleek, black exterior was coated with a special heat-resistant alloy designed to survive temperatures that would melt ordinary aircraft. Inside its structure lay sensors, wiring, and instruments built to gather data at speeds and altitudes far beyond anything known at the time. But the true heart of the X-15 was its engine, the powerful reaction motors XLR-99. This was not a traditional aircraft engine. It was a rocket, delivering thrust so immense that it propelled the aircraft from subsonic flight to hypersonic velocity in less than 2 minutes. This engine burned liquid oxygen and anhydrous ammonia, creating a roaring flame powerful enough to lift the aircraft to the very edge of space. The intensity of this thrust meant that once the engine ignited, the pilot had no turning back. Every flight was a controlled leap into the unknown. The pilots, navigators of the edge. To fly the X-15 required more than skill. It required extraordinary bravery. The pilots who took the controls were among the finest aviators of their time. Men like Neil Armstrong, Joe Walker, Scott Crossfield, and Pete Knight. Individuals who understood the risks and accepted them with unwavering discipline. Inside the cramped cockpit, they faced crushing acceleration, extreme vibration, and temperatures that soared due to atmospheric friction. At high altitudes, the sky around them faded from blue to black. Below them, the Earth curved gently, a sight few humans had ever witnessed. Every mission demanded complete focus. A small mistake could cause the aircraft to tumble, disintegrate, or enter a spin from which recovery was impossible. And yet, flight after flight, these pilots pushed forward, gathering insights that expanded our understanding of aerospace engineering. Their courage was not reckless. It was purposeful. They risked themselves so that humanity could learn, advance, and one day reach space with confidence, breaking records and breaking barriers. The X-15 did not merely perform well, it shattered boundaries. It reached speeds of more than Mach 6.7, exceeding 7,200 kilometers per hour. At such velocity, air molecules striking the aircraft generated surface temperatures hot enough to weaken metal. Every flight was a battle against the forces of nature. The aircraft also climbed to altitudes exceeding 100 kilometers, crossing into what we now define as the boundary of space. For their achievements, several X-15 pilots were awarded astronaut wings, a rare honor for individuals flying a machine that launched not from a rocket pad, but from the wing of a B-52 bomber. Through these achievements, the X-15 accomplished something greater than setting records. It proved that humans could control a high-performance craft at hypersonic speeds and near-space conditions. This knowledge became the foundation of future spacecraft design, a laboratory among the stars. At its core, the X-15 was a scientific platform. Every flight gathered data on aerodynamics at Mach 5+, heating and thermal stress, control systems in thin atmospheres, pilot response under extreme G-forces, the behavior of metals at high temperature, reentry dynamics, and the limits of human physiology. These findings directly influence the development of the space shuttle, modern crew capsules, military hypersonic projects, and even conceptual spacecraft designs we explore today. In many ways, the X-15 was a bridge between the first powerful jet aircraft and the earliest reusable spacecraft. It provided answers that no wind tunnel, no simulation, and no theory could fully predict. The legacy that still shapes our future. Although the X-15 program concluded in 1968, its legacy remains alive. Engineers designing future hypersonic aircraft still refer to X-15 data. Space agencies continue to rely on insights gathered from its missions. The courage of its pilots still inspires new generations of aviators, scientists, and explorers. To speak of the X-15 is to speak of human determination. It represents a moment in history when boundaries were not simply tested, they were rewritten. It is a reminder that progress is made when curiosity triumphs over fear, when science triumphs over uncertainty, and when the desire to explore becomes stronger than the comfort of staying within limits. The X-15 did not only show us how to reach the edge of space, it showed us why we must keep reaching. Closing. Ladies and gentlemen, the story of the legendary X-15 is more than a chapter in engineering. It is a testament to the human spirit, bold, curious, and determined to understand a universe beyond our sky. May its legacy continue to inspire us to seek the unknown, to challenge the limits before us, and pursue discoveries that push humanity forward. Thank you